Hello, and welcome to another gentle journey on Sleepy Professor Stories. Tonight, you are invited to drift softly outward, beyond the quiet space around you, into something far wider and calmer than the room you rest in now. The universe often feels like a place of enormous distance and complexity. Yet when we explore it slowly, with patience and quiet curiosity, it reveals patterns that feel surprisingly gentle. Stars glow steadily across immense stretches of time. Galaxies move in slow spirals that take hundreds of millions of years to complete. Even light itself travels patiently through space, carrying stories from faraway places. As we spend this time together, there is no rush to understand everything. Instead, we simply wander through a few peaceful ideas about the universe and the calm rhythms that shape it. You might imagine yourself floating quietly through deep space, watching distant stars shine like soft lanterns in the dark. Each small piece of knowledge becomes like a quiet stepping stone, guiding the mind farther into a feeling of calm wonder. If these slow explorations help you relax at night, you might choose to like the video, subscribe, or leave a small comment so others can discover this peaceful corner of science as well. But for now, none of that is important. There is nothing you need to do. No notes to remember, no ideas you must hold on to. Just allow yourself to settle into stillness. Let your breathing slow gently. Feel the muscles in your shoulders soften and allow the quiet of the night to support you. The universe is vast, patient, and unhurried, and tonight you can explore it in exactly the same way. Let's begin. And as your mind drifts outward into the calm darkness beyond Earth, it becomes natural to first notice something simple yet extraordinary: the quiet vastness of space itself. When you look up at the night sky, the first thing you may notice is the darkness. Between the small pinpoints of starlight stretches a deep and endless blackness, quiet and calm. It might seem empty at first, like a great ocean without waves. Yet the more carefully scientists observe this darkness, the more they realize it is not truly empty at all. Space is more like a vast, gentle sea made of subtle energy, faint particles, and invisible forces that quietly shape everything within it. You can imagine space as an enormous canvas stretching far beyond the edges of imagination. On this canvas, stars and galaxies appear like soft brushstrokes of light. But the background itself, the calm darkness behind them, is just as important. Without that quiet openness, there would be no room for galaxies to drift, for planets to circle their stars, or for light to travel across the universe. Even in the deepest regions of space, tiny particles move slowly through the darkness. These particles may come from distant stars, from ancient cosmic events, or from gentle streams of energy that pass silently through the universe. They are so small and spread so far apart that space still feels almost perfectly still. Yet their presence reminds us that the universe is never truly empty. It is always quietly alive with motion too subtle for the eye to see. As you rest and listen, you might picture this vast openness as a calm cosmic ocean. Unlike the oceans on Earth, there are no waves crashing and no winds stirring the surface. Instead, the universe moves with an extraordinary patience. Some motions take millions of years to complete, others take billions. From the perspective of human life, these changes unfold so slowly that they appear almost perfectly still. Light itself travels through this quiet expanse with remarkable steadiness. When a distant star releases its glow, the light begins a long journey through space, moving at a constant speed that never grows tired and never slows down. For years, decades, or even billions of years, that light continues across the darkness, until eventually, if conditions allow, it reaches a planet, a telescope, or perhaps even a human eye looking gently toward the sky. What is peaceful about this journey is its simplicity. Light does not rush or struggle. It simply moves forward, second after second, carrying information from faraway places. When astronomers study this light, they are not just seeing brightness, they are reading messages from the universe's past. A star shining tonight may actually be showing you what it looked like long before the first humans ever walked the Earth. Between these slow travelers of light lies the great openness that allows the universe to breathe. Space provides the room for galaxies to drift slowly apart and for new stars to form quietly within clouds of gas. It acts like a stage large enough to hold every cosmic story, from the birth of stars to the calm motion of distant worlds. The emptiness of space also carries an unusual stillness because sound cannot travel through it. On Earth, sound moves through air as tiny vibrations. But the vast regions between stars contain almost no air at all. Without a medium to carry those vibrations, sound simply fades away. This means that much of the universe unfolds in complete silence. You can imagine enormous cosmic events happening far away. Stars forming, galaxies slowly turning, clouds of gas drifting through space. And yet all of it occurs without a single audible sound. The universe is full of motion, but it is a motion wrapped in silence. This silence is part of what makes the night sky feel so calming when you look at it. The stars appear steady and patient, quietly shining across distances so vast that the mind does not need to measure them. Instead, you can simply notice the gentle pattern of lights scattered across the darkness, like lanterns placed along an endless path. Space itself also stretches in ways that feel almost impossible to picture. The distance between stars is so large that if our solar system were shrunk down to the size of a small coin, the nearest star would still be several kilometers away. The universe is built on scales far beyond everyday experience, yet these enormous distances also create a sense of peaceful separation. Stars have room to shine without crowding one another. Galaxies glide through space with vast gaps between them. Everything unfolds slowly and gracefully, guided by forces that have been working quietly since the earliest moments of cosmic history. Gravity is one of those quiet guides. Even across enormous distances, gravity gently connects objects throughout space. It pulls stars into clusters, gathers galaxies into groups, and shapes the graceful curves of cosmic structures. Yet gravity does not act suddenly or violently across the universe. It works patiently, drawing things together over immense periods of time. Because of this, the large-scale structure of the universe resembles something soft and flowing. Astronomers who map distant galaxies often find patterns that look almost like delicate threads or webs stretching across the cosmos. Along these long strands, galaxies gather together, leaving wide-open spaces between them. When viewed from this perspective, the universe appears less like a chaotic scattering of objects and more like a peaceful network slowly evolving over time. Even the temperature of space reflects this calm stillness. Away from stars and planets, the universe becomes extremely cold. With almost no matter to hold heat, the energy spreads thinly across the vast emptiness. The background temperature of space rests only a few degrees above absolute zero, the coldest temperature possible in nature. Yet even in this deep cold, faint energy remains. A gentle glow fills the universe in the form of ancient radiation left over from the early moments after the cosmos first began expanding. This faint warmth drifts quietly through space, surrounding galaxies and stars like a subtle cosmic whisper. Scientists often describe this background radiation as a kind of memory carried by the universe itself. It is a soft echo of a time when everything was closer together and far hotter than it is today. Now, billions of years later, that ancient energy still moves silently through space, almost unchanged. As you listen and rest, as you might imagine this ancient glow drifting gently through the darkness, crossing vast distances with the same quiet patience as starlight. The universe holds many such long journeys, stories that unfold slowly enough to feel timeless. What is comforting about this enormous scale is that the universe never seems to hurry. Stars take millions of years to form. Galaxies rotate slowly over hundreds of millions of years. Even the expansion of space itself happens gradually, stretching the cosmos little by little over billions of years. In this way, the universe moves more like a slow breath than a sudden event. And as you continue to relax, allowing the rhythm of these ideas to settle into your thoughts, the vastness of space begins to feel less like an empty darkness and more like a calm foundation upon which everything else gently unfolds. Because within this quiet expanse, scattered like distant islands of light, are the stars themselves, each one sending out small streams of brightness that travel patiently through the darkness, waiting to be discovered. When you look gently into the night sky, the stars appear quiet and immediate, as though they are shining right now in this very moment. Their light seems simple and direct, tiny points glowing against the deep darkness. Yet what you are seeing is not only the present. In many cases, you are seeing something far older, a message that began its journey long before you ever lifted your eyes toward the sky. Light moves across space with remarkable patience. It travels incredibly fast, faster than anything else known in the universe. And yet, the distances between stars and galaxies are so enormous that even light must spend long stretches of time crossing them. A beam of light leaving a distant star may travel for years before reaching Earth. Sometimes it travels for thousands of years, sometimes for millions. This means that when you notice a star tonight, the light touching your eyes often began its journey long ago, perhaps before entire civilizations rose and faded on Earth. The star may have changed since then, growing brighter or dimmer, but the light arriving here still carries the story of how it once was. You can imagine this light as a quiet traveler moving steadily through the calm ocean of space. It does not rush or hesitate. It simply continues forward, moment after moment, crossing immense distances in complete silence. Along its path, there are no winds, no waves, and no sounds. Only the stillness of space and the gentle motion of light itself. Because of this steady movement, the universe becomes something like a vast archive of memories. Each star sends out a continuous stream of light, and every beam carries information about the star that produced it. By the time that light reaches Earth, it becomes a small piece of cosmic history arriving softly in the present moment. When astronomers observe these distant lights through telescopes, they are not only seeing brightness, they are studying messages from the past. The colors of starlight reveal the temperature of distant stars. Subtle patterns in the light reveal the elements glowing within them. In this way, light becomes a quiet storyteller, carrying clues across space and time. The farther away a star or galaxy is, the longer its light has traveled to reach us. Some galaxies are so distant that the light we see tonight began its journey billions of years ago, when the universe itself was still young. By observing that ancient light, scientists can learn what the cosmos looked like long before our solar system even existed. You might picture this as standing beside a calm river where the water flowing past carries reflections from far upstream. Each reflection reveals something about a place the water has already passed. In a similar way, the light reaching Earth tonight reveals moments from the distant past of the universe. This gentle delay between events and observation is one of the quiet wonders of astronomy. It means that when you look deep into space, you are also looking backward through time. The night sky becomes something like a window through which the universe reveals its long history. Even our own sun sends light on a small journey before it reaches us. Though the sun is much closer than the stars scattered across the galaxy, its light still travels through space for several minutes before arriving at Earth. The warmth you feel on your skin during the day began its journey inside the sun's bright surface moments earlier. Within the sun, energy forms through powerful processes deep in its core. Atoms join together, releasing tremendous energy that slowly moves outward through the sun's interior. Eventually, that energy emerges as sunlight, beginning its brief but important voyage across space toward our planet. By the time the sunlight reaches Earth, it carries the energy that warms oceans, stirs winds, and supports life across forests and fields. In this way, light is not only a messenger from distant places, it is also the quiet source of energy that shapes the rhythms of our own world. Far beyond the sun, light continues its endless journeys through the universe. Some beams cross entire galaxies before reaching empty stretches of space. Others travel past clouds of gas and drifting dust. Occasionally, light bends slightly as it passes near massive objects whose gravity gently curves the path of space itself. This bending of light reveals another subtle truth about the universe. Space is not perfectly flat and rigid. Instead, it can curve gently around massive objects like stars or galaxies. When light passes through these curved regions, its path shifts slightly, as though it is following the soft contours of an invisible landscape. Astronomers sometimes observe distant galaxies, whose light has been bent in this way by objects lying between them and Earth. The result can create delicate arcs or stretched images in the sky, as though the universe itself is quietly shaping the view. Even after traveling across unimaginable distances, light remains faithful to its journey. It does not grow tired or fade away without reason. It simply continues moving forward until something interrupts its path, perhaps a planet's surface, a telescope mirror, or a human eye gazing upward during a quiet night. When light finally arrives, it does so instantly, touching the world with the same energy it carried across its entire journey. A photon that began its voyage in a distant galaxy billions of years ago ends its long travel in a single moment of contact. This idea can feel both vast and peaceful at the same time. The universe becomes a place where messages travel slowly, yet faithfully across immense distances, linking distant moments together. Even the faint glow that fills the universe from its earliest times continues traveling quietly today. Long ago, when the universe was younger and much hotter, energy filled every corner of space. As the cosmos expanded and cooled, that ancient energy stretched and softened, becoming a faint background glow that still surrounds everything. Sensitive instruments can detect this gentle radiation arriving from all directions. It is incredibly faint, yet it serves as a quiet reminder that the universe carries echoes of its earliest moments. So whenever you gaze toward the stars, you are not simply seeing distant objects shining in the darkness. You are witnessing light that has traveled patiently through space, sometimes for periods longer than the entire history of human civilization. The night sky becomes a soft tapestry woven from countless journeys of light, each thread stretching backward through time. And as these silent travelers continue their steady motion across the calm darkness of space, they eventually lead us toward the places where many of those beams first began their journey. Deep within vast clouds where new stars slowly come into being. When you look at a star in the night sky, it seems steady and complete, like a small lantern glowing quietly in the darkness. Yet every star begins its life in a far softer way, emerging slowly from clouds so large and delicate that they drift across space almost like mist. These clouds are made mostly of hydrogen gas, mixed with traces of other elements and tiny grains of cosmic dust. They float through the galaxy in enormous shapes that stretch for many trillions of kilometers. From a distance, they appear calm and silent, sometimes glowing faintly where nearby starlight brushes across them. Inside these drifting clouds, the universe prepares the beginnings of future stars. At first, the gas within the cloud spreads gently across vast distances. The particles move slowly, barely touching one another. The cloud may remain this way for long stretches of time, drifting through the galaxy like a quiet fog between the stars. Yet gravity is always present, even within these thin clouds. Gravity is a quiet force, patient and persistent. It gently pulls matter toward other matter, encouraging particles to move closer together. Over immense periods of time, this subtle attraction begins to gather small regions of the cloud into slightly denser pockets. These pockets grow slowly, almost imperceptibly. As more gas drifts inward, the growing region becomes heavier, and gravity begins to pull even more material toward it. What begins as a faint concentration of gas gradually becomes a soft center of gathering matter. You might imagine it like a calm snowfall settling across a field, where certain places slowly collect deeper layers of snow. In a similar way, the cloud gathers itself into quiet centers where future stars will eventually form. As this process continues, the gas within these regions becomes slightly warmer. The particles begin to move more quickly as they press closer together. Still, everything unfolds with extraordinary patience. A single forming star may spend millions of years slowly drawing matter inward before it ever shines. Eventually, the growing mass begins to collapse more noticeably under its own gravity. Gas flows inward toward the center, creating a dense and slowly spinning core. Around this core, a flattened disk of gas and dust begins to form, rotating gently like a quiet whirlpool in space. At the heart of this spinning cloud lies what astronomers call a protostar. It is not yet a true star, but it is the beginning of one. The protostar glows faintly with warmth created by the pressure of gas falling inward. As the core continues to gather matter, the temperature rises steadily. Deep inside the growing center, the gas becomes incredibly dense and hot. The pressure builds slowly, like the gradual brightening of dawn before the sun rises. For a long time, the protostar remains wrapped in the thick cloud that formed it. From far away, it may appear hidden, its light dimmed by layers of dust surrounding it. Yet within that cocoon, the star is quietly preparing for the moment when it will begin to shine on its own. Inside the core, hydrogen atoms begin to move with tremendous energy. When the temperature grows high enough, these atoms start to join together through a process known as nuclear fusion. In this reaction, hydrogen atoms combine to form helium, releasing enormous energy in the process. This energy creates the steady glow that defines a star. The moment fusion begins, the star reaches a delicate balance. Gravity continues pulling matter inward, while the energy produced in the core pushes outward. When these two forces balance each other, the star stabilizes and begins the long phase of its life where it shines steadily. From this point forward, the star becomes a true source of light. The surrounding cloud gradually clears as radiation and stellar winds gently push the remaining gas outward. What was once a thick cocoon of dust slowly thins, allowing the newborn star's light to spread across space. Around many young stars, the rotating disk of leftover gas and dust continues circling the center. Over time, this disk may gather into small clumps that grow larger through gentle collisions. These clumps can eventually form planets, moons, and other objects that travel around the star. In this way, the birth of a star often becomes the beginning of an entire solar system. Throughout the galaxy, this quiet process unfolds again and again. The enormous clouds slowly gather themselves into stars, each one beginning its life with the same patient rhythm. Some stars grow much larger than our sun, burning brighter and hotter. Others remain smaller and cooler, shining gently for billions of years. The size of the forming star depends largely on how much gas the original cloud gathers into its center. Yet, no matter the final size, the early stages remain similar. A calm cloud drifts through space. Gravity gathers its particles. A dense core forms. Heat builds slowly until fusion begins, and a star is born. What is remarkable is the timescale of these events. The formation of a single star may take longer than the entire history of human civilization. The universe does not rush this process. It allows the slow shaping of stars to unfold across millions of years. If you imagine watching a cloud collapse into a star in real time, the motion would appear almost perfectly still. The changes happen so gradually that even over a human lifetime, very little difference would be visible. This slow pace gives the universe a feeling of calm continuity. Across the Milky Way galaxy alone, hundreds of billions of stars shine today, many of them born from similar clouds long ago. Some of these stellar nurseries still exist, glowing softly as new stars continue to form within them. Astronomers often observe these regions through special telescopes that reveal the faint warmth of dust and gas hidden inside the clouds. These images show delicate shapes where gravity is quietly sculpting the next generation of stars. Some of the most beautiful regions in the galaxy are these star-forming clouds, where glowing gas spreads across space in gentle colors created by starlight passing through them. Within those clouds, new stars are forming right now, continuing the long story of cosmic creation. And when you look toward the night sky, many of the stars you see once began exactly this way. Inside vast clouds drifting slowly through the galaxy, gathering themselves over ages until their quiet light finally appeared. Each star becomes a small beacon shining across immense distances, sending out streams of light that travel patiently through the calm darkness of space. Those beams of light may cross clouds of gas, drift past distant planets, and move through the quiet stretches between stars before finally reaching places like our own world. And as these newborn stars begin to fill the galaxy with their steady glow, they gradually gather into larger families of light, vast systems where billions of stars move together through the universe. When you imagine space, you might first picture darkness scattered with bright stars. Yet, between many of those stars drift enormous clouds of gas and dust, so vast and delicate that they resemble gentle fog stretching across the galaxy. These quiet formations are known as nebulae, and they are among the most peaceful and beautiful structures in the universe. A nebula is not a solid object. It is more like a soft gathering of gas that spreads across enormous distances. Hydrogen gas forms most of the cloud, mixed with small amounts of helium and traces of heavier elements created long ago inside stars. Tiny grains of cosmic dust float within the gas as well, each particle smaller than a grain of sand, yet together, forming shapes large enough to span many light years. If you could travel into one of these clouds, you would not feel as though you had entered a dense mist like those found on Earth. The gas inside a nebula is extremely thin. The particles are spread so far apart that even within the cloud, space still feels mostly empty. Yet when light from nearby stars passes through the gas and dust, the cloud begins to glow softly, revealing its graceful structure. Some nebulae shine because nearby stars illuminate them. Their light scatters gently across the drifting gas, creating subtle colors and glowing edges that slowly shift over time. Other nebulae glow for a different reason. The gas within them becomes energized by radiation from hot stars, causing the atoms to release faint light of their own. When telescopes capture images of these regions, they often reveal shapes that look almost like floating curtains or slow-moving waves. But these shapes are not fixed. Nebulae change gradually as gravity, radiation, and gentle stellar winds move the gas through space. The transformations unfold so slowly that the clouds appear almost frozen in time, even though they are constantly evolving. Many nebulae serve as the quiet birthplaces of stars. Inside these clouds, regions of gas slowly gather under the influence of gravity. Over millions of years, those regions grow denser until they begin the long process of forming new stars. In this way, nebulae become vast stellar nurseries where the next generation of stars slowly emerges. Within these star-forming clouds, the pockets of gas collapse inward while the surrounding dust helps shield them from outside radiation. This shelter allows the material to cool and gather more easily. As the mass grows, the forming star begins to warm, eventually shining through the surrounding cloud that once hid it. The light of these newborn stars often illuminates the remaining gas around them, causing the nebula to glow even more brightly. What once appeared as a dark and quiet cloud gradually becomes a softly glowing region filled with young stars spreading their light outward. Yet nebulae are not only places where stars begin. Some of them mark the final moments in the long life of a star. When certain stars reach the end of their existence, they gently release their outer layers into space. These expanding shells of gas drift outward, forming delicate glowing clouds that gradually spread into the surrounding darkness. Over time, these remnants create some of the most intricate nebulae seen by telescopes. In these clouds, the elements forged inside the star during its lifetime are released into the galaxy. Carbon, oxygen, and other atoms that form deep within the star become part of the drifting gas. Later, these elements may join new clouds where future stars and planets begin to form. In this way, nebulae quietly recycle the materials of the universe. Matter that once belonged to an ancient star slowly becomes part of new cosmic structures. The dust within these clouds also plays an important role. Although the dust particles are incredibly small, they help shape the appearance of nebulae by absorbing and scattering light. In some regions, thick concentrations of dust block light from behind them, creating dark lanes that weave through the glowing gas like gentle shadows. These dark shapes can look like soft rivers flowing through the luminous clouds. In reality, they are simply areas where the dust is thick enough to hide the light behind it. Astronomers often observe nebulae in different kinds of light to understand their structure more clearly. While visible light shows the glowing surfaces of the clouds, other forms of light reveal the hidden regions inside them. Infrared observations can see through dust that blocks ordinary light, revealing young stars still wrapped in their birth clouds. Through these observations, scientists learn how nebulae evolve over time and how stars slowly gather within them. And some nebulae stretch across regions so large that light itself takes years to cross them. To picture this scale, imagine a cloud so enormous that even light traveling faster than anything else in the universe still needs years to move from one side to the other. And yet, despite their immense size, nebulae remain incredibly delicate. The gas within them is spread so thin that even a gentle push from starlight can slowly reshape the cloud. Over long periods, radiation from nearby stars carves pillars, arcs, and flowing shapes into the gas. These structures appear almost sculpted, though no hand shapes them directly. Instead, they form through the quiet interaction between light, gravity, and drifting gas. Some nebulae glow in soft reds, others in pale blues or subtle greens. These colors arise from the way different elements release light when energized by nearby stars. Hydrogen often produces a gentle red glow, while oxygen can create bluish or greenish tones. The colors reveal the chemical ingredients floating inside the cloud, allowing astronomers to understand what elements are present. Even with their beauty, nebulae remain calm places in the universe. The processes within them unfold slowly, guided by forces that operate across millions of years. Gas gathers, stars form, and light spreads outward, all with the same quiet rhythm that shapes the rest of the cosmos. If you imagine drifting through such a cloud, you would see faint glows spreading across enormous distances, with newborn stars slowly brightening within the mist. Everything would appear peaceful and unhurried, now like a cosmic sunrise that takes ages to unfold. Across the Milky Way galaxy, countless nebulae float between the stars. Some are bright and active, filled with young stellar light. Others are dim and quiet, waiting patiently as gravity slowly gathers the gas that will one day ignite new stars. These clouds remind us that the universe often builds its grandest structures through gentle beginnings. Soft gas drifts through space. Gravity gathers it slowly. Light begins to glow. And over time, the quiet clouds shape the future of entire star systems. And as these glowing mists continue drifting through the galaxy, they eventually reveal something even larger unfolding across the cosmos. Immense gatherings of stars, dust, and nebulae themselves, slowly moving together through space like luminous islands in a vast and silent ocean. When you step outside on a clear night and look gently upward, the sky may appear scattered with individual stars, each shining quietly in its own place. Yet what you are seeing is only a tiny portion of a much larger structure. Those stars belong to a vast gathering known as a galaxy, a slow-moving community of light drifting through the immense calm of space. A galaxy is an enormous collection of stars, gas, dust, and invisible matter, all held together by the quiet pull of gravity. These cosmic families can contain hundreds of billions of stars, each one shining with its own steady glow. Around many of those stars travel planets, moons, and drifting clouds of gas, forming countless small systems within the larger whole. From far away, galaxies resemble glowing islands floating in a dark and silent ocean. Their light gathers into graceful shapes that slowly rotate through the universe. Some stretch outward in delicate spirals, their arms curling softly around a bright central region. Others appear round and smooth, like glowing spheres made of countless tiny points of light. Our own home in the universe lies inside such a structure. The galaxy that surrounds us is called the Milky Way, a vast spiral containing an extraordinary number of stars. When you see the faint band of light stretching across the night sky on very dark nights, you are actually seeing the combined glow of millions of distant stars within that galaxy. Because we live inside this great system, it can be difficult to see its full shape from our position. It is similar to standing within a forest where trees surround you in every direction. From the ground, the forest may seem endless, even though from above it reveals its full structure. Astronomers learn about the shape of our galaxy by studying the motion of stars and the faint glow of gas clouds spread throughout its disk. These observations reveal a large spiral structure slowly rotating through space, with long arms extending outward from a brighter central region. Within those arms, stars form, shine, and eventually fade over immense spans of time. Some stars burn brightly and live relatively short lives. Others glow gently for billions of years. Together, they create the soft radiance that fills the galaxy. Galaxies themselves are not isolated. Across the universe, countless others drift quietly through the darkness. Some are smaller and contain only a few million stars. Others are so vast that they hold trillions. Each galaxy follows its own path through space, guided by gravity and shaped by the slow history of cosmic evolution. When astronomers look through powerful telescopes, they see that the universe is filled with these distant gatherings of light. In some regions, galaxies appear scattered like faint sparks across the darkness. In others, they gather in loose groups or larger clusters, gently orbiting one another across enormous distances. Within these clusters, gravity binds galaxies together into slow-moving communities. Over time, their paths may bring them close enough to influence each other. In rare cases, two galaxies drift near and begin a slow cosmic dance, their shapes stretching and bending under the pull of gravity. These interactions unfold over millions or even billions of years. Stars themselves rarely collide during such encounters because the distances between them are so vast. Instead, the overall structure of the galaxies slowly reshapes as gravity guides their motion. Through these gentle encounters, galaxies can merge together, forming larger systems that continue drifting through space. The process is gradual, almost serene when imagined across cosmic time. At the centers of many galaxies lies an especially intriguing feature. Hidden within the dense central regions is often an extremely massive object whose gravity helps hold the surrounding stars in their graceful orbits. Though invisible directly, its presence reveals itself through the motion of nearby stars and gas. This central anchor quietly influences the entire structure of the galaxy, guiding the slow motion of stars that circle around it. Across the disk of a galaxy, enormous clouds of gas drift between the stars. Within these clouds, new stars may begin forming, continuing the long cycle of cosmic creation. As stars age and release their material back into space, that matter becomes part of new clouds where future stars may arise. In this way, galaxies act as vast ecosystems of matter and energy. Gas gathers into stars, stars shine and evolve, and their material eventually returns to the surrounding clouds. Dust also plays a subtle role in shaping the appearance of galaxies. Thin lanes of cosmic dust weave through the spiral arms, sometimes blocking light from the stars behind them. These dark ribbons create delicate patterns that contrast with the glowing star fields around them. When telescopes capture images of distant galaxies, the view often resembles something almost artistic, swirling patterns of light suspended within darkness. Yet the beauty of galaxies does not come from sudden events or dramatic motion. It comes from the slow and steady processes unfolding over unimaginable stretches of time. Stars orbit the center of the galaxy at speeds that seem fast by everyday standards. Yet their paths are so vast that a single orbit may take hundreds of millions of years to complete. During that time, civilizations may rise and fall many times on distant planets, while the galaxy itself continues its calm rotation. Even our own sun participates in this quiet movement. As it travels around the center of the Milky Way, it carries the entire solar system along with it, drifting gently through the galaxy's spiral arm. The sun's path through the galaxy is so large that it takes hundreds of millions of years to complete one full journey. From our human perspective, this motion feels almost perfectly still. Beyond the galaxies, we can easily observe lie many more, extending across the universe in every direction. The light from some of them has traveled billions of years before reaching our telescopes. Each distant glow represents an entire galaxy filled with stars, planets, and clouds of gas. When scientists map the positions of these galaxies, they discover patterns that stretch across enormous distances. Galaxies gather along long strands and clusters, forming a vast cosmic structure that resembles a delicate web. Between these strands lie immense regions where very few galaxies appear at all. The universe becomes a tapestry of light and emptiness, woven together on the largest scales imaginable. Despite these immense distances and structures, the universe remains calm and unhurried. Galaxies drift slowly through space, their stars shining quietly across the darkness. If you imagine stepping far beyond the Milky Way and looking back toward it from afar, You might see a glowing spiral slowly turning, its arms filled with stars and drifting clouds. And somewhere within one of those spiral arms, a small yellow star shines gently, surrounded by a few quiet planets. From that small world, a listener rests peacefully, hearing about the immense structures that surround them. The universe, vast as it is, holds everything within its quiet embrace. And as these luminous islands of stars continue their slow journeys across space, they move according to an even deeper and more patient force, one that quietly guides the motion of galaxies, stars, and planets alike. When you watch the night sky, the stars appear steady and peaceful, resting quietly in their places across the darkness. Yet behind this calm appearance, an invisible force is gently guiding nearly every motion in the universe. This quiet influence is known as gravity. Gravity does not glow or shimmer. It cannot be seen directly. Yet its presence is felt everywhere, shaping the paths of planets, guiding the movements of stars, and gathering entire galaxies into vast cosmic families. It works patiently, always pulling objects toward one another with a steady and gentle persistence. You experience gravity every day without needing to think about it. It is the reason your feet remain on the ground and why the oceans stay wrapped around the surface of Earth. It keeps the air close to the planet, allowing life to breathe and grow. Even the simple act of placing your hand on a table is guided by gravity, drawing you gently toward the surface below. In the wider universe, gravity acts in much the same quiet way, though across distances far greater than anything we encounter on Earth. It connects objects that may be separated by millions of kilometers, guiding their motions through space with calm precision. Imagine two objects drifting through space. Even if they are separated by great distances, gravity gently pulls them toward one another. The pull is subtle at first, but over time it becomes more noticeable. Slowly, their paths curve inward, guided by the invisible thread of gravitational attraction. This quiet influence is what allows planets to travel around stars in smooth, repeating paths. Earth, for example, moves through space at tremendous speed as it circles the Sun. Yet, instead of flying away into darkness, gravity holds the planet in a graceful orbit. You might picture this motion like a stone swinging on the end of a string. The stone moves forward, but the string gently pulls it inward, creating a curved path. In space, gravity acts like that invisible string, guiding the motion of planets without ever needing to touch them directly. Because of gravity, the Earth completes its calm journey around the Sun once every year. This steady motion shapes the seasons, bringing cycles of warmth and coolness that quietly influence life across the planet. The Moon also follows a similar path. Held by Earth's gravity, it travels around the planet in a peaceful orbit, reflecting sunlight into the night sky. Its steady motion has guided human curiosity for thousands of years, inspiring stories, calendars, and quiet moments of reflection beneath the stars. Gravity works not only between planets and moons, but also between stars themselves. Within galaxies, countless stars move through space while still remaining part of a larger system. Gravity gently pulls them toward the central regions of their galaxy, guiding their slow journeys through the cosmic landscape. Each star follows its own path, yet together they create the graceful rotation of an entire galaxy. The movement is so vast and gradual that it takes hundreds of millions of years for a single star to complete one full orbit around the galactic center. From our brief human perspective, these enormous motions appear almost perfectly still. But over cosmic time, gravity slowly choreographs the dance of stars across the universe. Gravity also shapes the birth of stars themselves. Inside drifting clouds of gas and dust, gravity gently gathers material inward. As the gas draws closer together, pressure and warmth begin to build. Eventually, these growing regions form the glowing cores that become new stars. Without gravity, these clouds would remain scattered across space, never gathering into the bright points of light that fill the night sky. The same quiet force continues guiding matter long after stars are born. Around many stars, our leftover clouds of gas and dust begin to clump together under gravity's influence. Over time, these clumps grow into planets, moons, and smaller objects that orbit their star. In this way, gravity acts like a cosmic organizer, shaping scattered material into systems that remain stable for billions of years. Even galaxies themselves respond to this steady pull. Large galaxies often attract smaller ones, drawing them closer through the slow pull of gravity. When two galaxies approach each other, their shapes may stretch and curve as their stars respond to the shifting gravitational landscape. These encounters unfold slowly, taking millions of years to complete. Stars glide past one another without collision, while the galaxies gradually merge into a larger system. What might appear dramatic in images is actually a slow and peaceful process when viewed across cosmic time. Gravity also reveals itself in more subtle ways. Astronomers studying the motion of stars inside galaxies have discovered that visible matter alone cannot explain all of the gravitational pull they observe. Stars move as though additional unseen mass surrounds them. This discovery has led scientists to understand that much of the universe contains a form of matter that does not shine or reflect light. Though invisible, it contributes to gravity's influence, helping shape the motion of galaxies and clusters of galaxies across the cosmos. Even though this mysterious matter cannot be seen directly, its gravitational presence becomes clear through the gentle motions it creates. Another quiet feature of gravity emerges when massive objects bend the path of light traveling near them. When light passes close to a large galaxy or cluster of galaxies, gravity subtly curves the space around that mass. As a result, the light's path bends slightly. From Earth, this bending can cause distant galaxies to appear stretched into delicate arcs or repeated patterns in the sky. Astronomers sometimes call this effect gravitational lensing, because the massive object acts almost like a natural lens in space. Through these observations, gravity reveals not only its strength, but also its ability to shape the very fabric of space. What makes gravity so remarkable is its quiet reliability. It does not flicker or change suddenly. It operates with steady patience, guiding cosmic motion across billions of years. Planets continue their orbits. Stars circle the centers of galaxies. Galaxies drift slowly through clusters. All of these motions unfold through gravity's gentle guidance. In many ways, gravity acts like a silent conductor leading a vast orchestra. Each object in the universe follows its own path, yet together they create a harmonious pattern that stretches across the cosmos. And while gravity shapes the motion of galaxies and stars, it also influences regions where its pull becomes especially strong. In certain places, gravity gathers matter so densely that it forms some of the most mysterious structures known in the universe. When you look toward the stars on a quiet night, it can be easy to imagine each one shining alone in the darkness. Yet around many of those distant suns travel entire families of worlds. Planets drift quietly through space, following steady paths that unfold across immense stretches of time. These worlds do not appear suddenly. Their beginnings are gentle and gradual, forming from the leftover material that surrounds a young star after its birth. In the early days of a star's life, a wide disk of gas, dust, and small rocky fragments circles slowly around it. This disk rotates calmly, much like a quiet whirlpool spreading through space. Within this rotating cloud, tiny particles begin to brush against one another. At first, the collisions are soft and slow. Grains of dust touch and cling together through faint electrical forces. Over time, these small clusters grow larger as more material gathers around them. The process continues patiently. Pebble-sized pieces join with others to form objects the size of stones. Then boulders, then mountain-sized bodies drifting through the disk. Gravity begins to play a stronger role as these growing objects gain mass, gently pulling nearby material toward themselves. Eventually, some of these bodies become large enough that gravity gathers even more dust and rock around them. The growing objects begin shaping the disk around them, clearing gentle paths through the cloud as they continue collecting material. Through millions of years of quiet accumulation, some of these bodies become planets. Near the young star, where temperatures remain warm, the material tends to form rocky planets made of metals and stone. These worlds often have solid surfaces and may experience volcanic activity as their interiors remain warm. Farther from the star, the environment is colder. In these outer regions, ice and gas gather more easily. Planets forming here may grow very large, capturing thick envelopes of gas that surround a small solid core deep inside. The result is a variety of planetary worlds. Some are small and rocky, with landscapes shaped by mountains, valleys, and craters. Others are enormous spheres of swirling gas, their atmospheres stretching thousands of kilometers above hidden cores. Once a planet becomes established, it settles into an orbit around its star. This orbit is not random, but guided by the steady influence of gravity. The planet moves forward through space, while the star's gravity gently pulls it inward, creating a balanced path that curves gracefully around the star. From afar, the motion appears calm and repetitive, like a slow dance repeated across billions of years. Our own solar system offers a familiar example of this quiet choreography. The planets travel around the Sun in wide, steady paths that rarely change. Each world keeps to its own orbit, maintaining a delicate balance shaped by gravity and motion. Earth follows one such path, completing its journey around the Sun once each year. As the planet travels along this orbit, sunlight falls across its surface in shifting patterns, creating the changing seasons that influence life across the planet. Some planets rotate quickly, spinning once every few hours. Others turn slowly, taking months or even longer to complete a single rotation. These rhythms shape the day and night cycles that unfold on each world. Many planets also host companions, known as moons. On these smaller bodies form either from leftover material around the planet or from debris created during ancient collisions. Once formed, moons follow their own gentle orbits around their parent planets. In some cases, these moons become fascinating worlds of their own. Beneath icy surfaces, hidden oceans may exist, warmed by internal energy deep within the Moon's interior. In other cases, volcanic activity or shifting ice plains create landscapes unlike anything found on Earth. Throughout the universe, astronomers have discovered that planets are incredibly common. Observations reveal thousands of distant planetary systems orbiting stars across the galaxy. Many of these systems contain multiple planets, each following its own path around the central star. Some planets orbit very close to their suns, completing a full journey in just a few days. Others travel along enormous orbits that take many years to complete. The diversity of these systems reveals how flexible the process of planet formation can be. In certain systems, giant planets migrate inward over time, moving closer to their stars as they interact with the surrounding disk of gas. In others, planets remain in stable orbits that last for billions of years. Astronomers detect these distant worlds using careful observations of starlight. When a planet passes in front of its star from our point of view, the star's light dims slightly. By measuring these tiny changes, scientists can infer the presence of a planet. Other discoveries come from noticing subtle movements in a star's position. A planet's gravity can cause its star to wobble gently as both objects orbit a shared center of mass. These small shifts reveal the hidden presence of planets too distant to see directly. Through these techniques, astronomers have learned that many stars in the Milky Way likely host planetary systems. Some of these planets may resemble Earth in size and temperature. Others are far larger or exist in environments very different from our own. The variety of worlds suggests that the universe contains an extraordinary diversity of planetary landscapes. Even so, the basic rhythm remains similar across many systems. Planets form from disks of gas and dust. Gravity shapes their orbits. Over time, they settle into steady paths that continue for ages. The calmness of these motions is part of what makes planetary systems feel so stable. Once established, the orbits of planets can remain remarkably consistent across billions of years. This quiet stability allows stars to shine while their planets travel around them in predictable cycles. In some cases, these worlds may develop atmospheres, oceans, or climates shaped by the gentle warmth of their star. From the perspective of the universe, planets are like travelers moving along invisible roads through space. Each one follows a path determined long ago during the early days of its system. When you imagine these distant worlds drifting around their suns, the universe begins to feel less empty and more like a vast collection of quiet solar systems, each with its own rhythm and motion. Across the galaxy, countless planets circle their stars right now, moving calmly through the darkness. And as these worlds continue their silent journeys, many of them are accompanied by smaller companions that orbit faithfully beside them. Moons that follow their planets through space with the same steady patience. When you think of planets drifting through space, it can be easy to imagine them traveling alone, quietly circling their stars in wide, graceful paths. Yet many of these worlds are not solitary travelers. They are accompanied by smaller companions known as moons, bodies that follow their planets with the same gentle patience that planets follow their suns. Moons are natural satellites, worlds that orbit planets because gravity quietly binds them together. Some are small and irregular, shaped like rough stones drifting through space. Others are large enough to be considered worlds in their own right, with mountains, valleys, icy plains, and sometimes even hidden oceans beneath their surfaces. The relationship between a planet and its moon is calm and balanced. Gravity pulls the moon inward, while the moon's forward motion keeps it moving sideways through space. The result is a smooth, curved path, an orbit that repeats itself again and again over immense stretches of time. You might picture it like a slow dance, where one partner circles the other without ever colliding or drifting away. Earth's moon offers a familiar example of this quiet companionship. Night after night, the moon rises and travels across the sky, reflecting sunlight from the far side of Earth. Its orbit takes about a month to complete, creating the steady cycle of phases that humans have watched for thousands of years. At times, the moon appears as a slender crescent, softly glowing against the dark sky. Other nights, it becomes a full circle of light, illuminating landscapes and oceans with a pale silver glow. These changing shapes are not caused by the moon itself changing, but by the shifting angles between the sun, Earth, and the moon. The moon's gentle presence also influences the oceans of our planet. Its gravity pulls slightly on Earth's water, creating the slow rise and fall of tides along coastlines around the world. These rhythms unfold quietly, twice each day, guided by the steady pull of the moon above. Beyond Earth, the solar system reveals a remarkable variety of moons. Some planets host only one or two companions, while others are surrounded by dozens. Jupiter and Saturn, the great gas giants, possess entire families of moons that travel around them like miniature solar systems. Each of these moons follows its own path, some moving close to the planet, while others orbit much farther away. Their motions remain stable because gravity keeps them in delicate balance with the massive planet they circle. Among these distant moons are worlds that feel both strange and fascinating. One of Jupiter's moons, known as Europa, is covered in a smooth shell of ice that reflects sunlight like a frozen mirror. Beneath that icy surface, scientists believe there may be a deep ocean of liquid water warmed by energy from the moon's interior. Another moon, called Io, displays a landscape shaped by constant volcanic activity. Its surface is dotted with erupting volcanoes that release plumes of gas high above the moon's crust. Saturn's moon Titan offers yet another kind of environment. It possesses a thick atmosphere and lakes of liquid hydrocarbons spread across its surface, creating a world both familiar and alien at the same time. These examples reveal how moons can become complex worlds, shaped by their own internal processes and by their relationship with the planets they orbit. The origins of moons vary from system to system. Some form from the same swirling disks of gas and dust that create planets. In these cases, a young planet gathers material around itself, and small bodies gradually form within that surrounding disk. Other moons appear to have formed through dramatic events long ago. Scientists believe Earth's moon likely began after a large object collided with the early Earth, sending debris into orbit. Over time, that material gathered together, forming the moon we see today. Still, other moons may have begun as wandering objects traveling through space before being captured by a planet's gravity. Despite these different beginnings, the result is often the same: a quiet companion circling a planet with steady rhythm. The motion of moons can also influence the planets they orbit. Over long periods of time, gravitational interactions between a planet and its moon can change the rotation of the planet itself. In Earth's case, the Moon's pull has gradually slowed the planet's rotation across billions of years. Moons may also help stabilize the tilt of a planet's axis. This stability can influence climate patterns and seasonal cycles, shaping the long-term environment of the planet. Across the universe, moons appear to be common companions in planetary systems. As astronomers study distant worlds orbiting other stars, they suspect that many of those planets may also host moons of their own. Although detecting these distant moons remains difficult, their presence would not be surprising. The same gentle forces that form moons in our solar system likely operate elsewhere throughout the galaxy. When you imagine these distant systems, the picture becomes almost musical in its calm repetition. A star shines steadily at the center. Planets travel around it in wide arcs. Moons circle their planets in smaller paths. Layer upon layer of motion unfolds, each orbit steady and predictable, guided by gravity's quiet influence. These patterns continue across immense spans of time. A moon may circle its planet for billions of years, repeating the same path again and again, while stars shine and galaxies drift slowly through space. From our small perspective on Earth, these motions may feel distant and abstract, yet they are part of the same cosmic rhythm that shapes the entire universe. Even now, as you rest quietly, countless moons are circling their planets somewhere in the galaxy. Some reflect the light of nearby stars, while others remain dim and icy, drifting silently through the darkness. Each one participates in the gentle choreography of space, guided by the invisible pull of gravity. And in certain regions of the universe, gravity gathers matter even more strongly, creating places where its influence becomes so powerful that it bends light itself and shapes the motion of entire galaxies. When you think of gravity, you might picture the gentle pull that keeps planets circling their stars or moons, drifting faithfully around their planets. Yet, in certain rare regions of the universe, gravity gathers so intensely that it shapes space itself in extraordinary ways. These regions are known as black holes, places where gravity becomes so strong that even light cannot escape once it travels too close. Despite their dramatic name, black holes are not cosmic monsters racing through space. They are quiet, stable objects formed through natural processes that unfold across vast spans of time. Like many things in the universe, they arise slowly from the life cycles of stars and the steady influence of gravity. One common path toward the creation of a black hole begins with a very massive star. Such stars burn brightly during their lives, and producing enormous energy as nuclear fusion occurs deep within their cores. This energy pushes outward while gravity pulls inward, creating a delicate balance that allows the star to remain stable for millions of years. Eventually, however, the star exhausts the fuel that supports this balance. Without enough energy pushing outward, gravity begins to take control. The core of the star collapses inward under its own weight, compressing matter into an extremely dense state. If the collapsing core contains enough mass, the inward pull becomes unstoppable. The material continues collapsing until it forms a region so compact that gravity curves space around it in an extreme way. At this point, a black hole is born. What makes a black hole unique is the presence of a boundary called the event horizon. This boundary marks the point where gravity becomes strong enough that nothing moving slower than light can escape once it crosses that limit. Any matter or light passing inside remains trapped by the black hole's gravity. Yet outside this boundary, space behaves much as it does elsewhere. Objects can orbit a black hole just as planets orbit stars. In fact, many black holes quietly exist within galaxies, influencing the motion of nearby stars without swallowing everything around them. You might imagine the black hole as a deep valley in the landscape of space. Objects that wander too close may fall inward, but those that remain at a safe distance can circle calmly around it for long periods of time. Astronomers often discover black holes by observing the motion of nearby stars or clouds of gas. When a star orbits an invisible object with tremendous mass, scientists can infer that a black hole may be present. The black hole itself cannot be seen directly because it does not emit light, but its gravitational influence reveals its presence. In some situations, matter from nearby stars drifts toward a black hole. As this gas spirals inward, it forms a rotating disk that becomes extremely hot. The gas glows brightly as it moves closer and closer to the event horizon, releasing energy before eventually disappearing into the black hole. These glowing disks allow astronomers to detect black holes even from vast distances. Through careful observation, scientists have identified black holes scattered throughout our galaxy and far beyond. At the center of many galaxies lies a particularly large black hole, known as a supermassive black hole. These objects contain millions or even billions of times the mass of our Sun. They rest quietly at the hearts of galaxies, influencing the motion of stars across enormous regions. Our own galaxy holds such a central black hole deep within its core. Although it lies far from Earth and poses no danger to our solar system, its gravity plays a role in shaping the overall structure of the Milky Way. Stars near the galactic center orbit this massive object at remarkable speeds, tracing paths that reveal the hidden presence of the black hole within. Despite their immense gravity, black holes do not endlessly devour everything nearby. Most matter within a galaxy remains far enough away to continue its normal orbit around the galactic center. Black holes influence their surroundings, but they are only one piece of the larger cosmic structure. One of the most fascinating discoveries in modern astronomy occurred when scientists captured the first image of a black hole's shadow. Using a network of telescopes spread across Earth, astronomers combined their observations to reveal the dark silhouette of a black hole surrounded by glowing gas. The image showed a bright ring of light surrounding a central darkness, a visual confirmation of a region where gravity bends space and light in dramatic ways. Even so, the overall behavior of black holes remains calm when viewed across cosmic time. Matter drifts toward them slowly. Stars orbit around them in steady paths. Entire galaxies continue their gentle rotations despite the presence of these powerful objects. Black holes also play an important role in the evolution of galaxies. As matter falls toward a supermassive black hole, some of the energy released can flow outward into the surrounding galaxy. This energy may influence the formation of new stars by heating nearby gas clouds or pushing material away from the central regions. Through these interactions, black holes become quiet participants in the ongoing story of galaxies. Another remarkable property of black holes arises from the way gravity bends light around them. Light traveling near a black hole may curve dramatically as it passes through the warped region of space surrounding it. This bending can create rings or arcs of light as distant objects appear distorted by the strong gravitational field. Astronomers use these effects to study black holes and the matter around them. The patterns of light reveal how space behaves near these extreme objects. Even with all these discoveries, black holes remain deeply mysterious. Scientists continue exploring their properties through observation and theory, gradually uncovering the ways they influence the universe. Yet, when imagined on the scale of cosmic time, black holes remain part of the universe's quiet balance. They form from the natural life cycles of stars, shape the motion of matter around them, and slowly interact with the galaxies they inhabit. The universe often creates its most powerful structures through processes that unfold slowly and steadily. In the vast silence of space, black holes exist not as chaotic forces, but as calm centers of gravity where matter gathers and time itself behaves in unusual ways. And as you imagine these deep regions of gravity resting quietly within galaxies, it becomes natural to wonder about the tiny particles and drifting material that move through space between the stars, forming the subtle ingredients from which new worlds may one day grow. When you imagine the universe, it is easy to picture stars shining brightly and planets drifting quietly around them. Yet between these larger objects exists something much smaller and far more delicate. Floating through the calm darkness of space are tiny particles known as cosmic dust. These grains are incredibly small, often no larger than fine smoke particles. Some are made of carbon, others of silicates similar to the minerals found in rocks on Earth. Many formed long ago inside ancient stars, where intense heat allowed heavier elements to take shape before being released into space. When stars reach the later stages of their lives, some gently shed their outer layers. Gas and dust drift outward, spreading slowly across the galaxy. Over time, these particles mix with the existing material already present between the stars. The result is a thin but widespread veil of cosmic dust floating quietly throughout the Milky Way. Although each grain is tiny, together they influence the appearance of the universe in subtle ways. When starlight passes through clouds of dust, some of the light becomes scattered or absorbed. This creates soft shadows and glowing edges within nebulae and star-forming regions. Astronomers studying the night sky often see long, dark lanes weaving through bright clouds of gas. These shapes appear almost like rivers flowing across the glowing nebulae. In reality, they are areas where dense concentrations of dust block the light behind them. And dust also interacts with light in another gentle way. Some grains absorb energy from nearby stars and then release that energy again as faint warmth. Telescopes designed to detect infrared light can sense this quiet glow, revealing clouds of dust that would otherwise remain hidden. Through these observations, scientists learn that dust exists almost everywhere in the galaxy. Yet the most fascinating role of cosmic dust appears during the formation of planets. Around young stars, disks of gas and dust rotate slowly through space. Inside these disks, tiny grains drift and collide. When two grains meet, they may stick together through small electrical forces or through the gentle pull of gravity. At first, the clusters remain extremely small. But as collisions continue, the grains gradually form larger and larger particles. Dust becomes pebbles. Pebbles gather into rocks. Rocks merge into larger bodies drifting through the disk. Over immense stretches of time, these objects grow into the building blocks of planets. Without cosmic dust, the formation of solid worlds would be almost impossible. Dust provides the raw material from which rocky planets, moons, and even the surfaces of asteroids take shape. Many of the minerals found on Earth began their journey in this way, forming from ancient dust grains that gathered together billions of years ago. Cosmic dust also contains elements that play an important role in chemistry. Carbon, oxygen, nitrogen, and other atoms attach themselves to the surfaces of dust grains within cold clouds of gas. In these environments, simple molecules begin forming through natural chemical reactions. Over time, these molecules can become more complex. Some of the organic compounds discovered in space contain the same basic ingredients that later contribute to the chemistry of life. Scientists studying meteorites that fall to Earth sometimes find traces of these ancient molecules preserved within them. These fragments of space rock act like small time capsules, carrying material that formed long before our planet existed. In this way, cosmic dust may help distribute the ingredients needed for life throughout the galaxy. Dust also influences the temperature of interstellar clouds. By absorbing and releasing energy, dust helps regulate how quickly gas cools or warms within these regions. This subtle process can affect how easily new stars begin forming within the clouds. In many ways, dust acts as both a builder and a guide within the universe. It gathers into planets, shapes the structure of nebulae, and participates in the chemistry that unfolds inside interstellar clouds. Despite its importance, cosmic dust remains almost invisible to the naked eye. Each grain is far too small to be seen individually, and the clouds they form are spread across enormous distances. Yet, when enough dust gathers together and light passes through it, the result can be breathtaking. Telescopes reveal glowing clouds where dust reflects the light of nearby stars like a soft mirror. In other regions, dust forms delicate filaments and pillars sculpted by radiation flowing from young stars. These shapes appear almost like drifting sculptures carved into the cosmic mist. Dust grains also travel great distances over time. Stellar winds, supernova explosions, and the slow motion of gas clouds carry them through the galaxy. Some grains may spend millions of years drifting before becoming part of a new star system. During this long journey, the particles may experience intense radiation, gentle collisions, or freezing temperatures inside cold interstellar clouds. Yet, despite these conditions, many grains survive long enough to become part of new cosmic structures. When a new star forms within a cloud of gas and dust, the surrounding material begins rotating into a disk. Within that disk, dust again begins the slow process of gathering into larger bodies. Over millions of years, the dust that once floated freely through space may become part of planets, moons, or asteroids. In this way, the universe continually recycles its material. Dust created by ancient stars becomes the foundation for new worlds forming around young stars. You might imagine the galaxy as a vast workshop where matter is constantly reshaped and reused. Nothing remains unchanged forever. Instead, particles drift, gather, and transform across immense spans of time. Even the ground beneath your feet on Earth contains atoms that once traveled through this long cosmic journey. The elements within rocks, oceans, and living organisms all originated within stars and the clouds of dust that followed them. When you look at the night sky, you are seeing the glowing points of stars surrounded by enormous regions filled with this drifting material. Some of that dust will remain suspended in space for ages. some will gather into new stars and planets, as some may eventually become part of distant worlds where life might arise. The quiet motion of dust across the galaxy reminds us that the universe often builds its most complex creations from the smallest beginnings. Tiny grains drifting through darkness eventually gather into landscapes, oceans, and living systems. And as these particles continue their slow journeys through space, they also move within a universe that itself is gradually changing in scale, stretching outward in a calm expansion that carries galaxies farther apart over time. When you gaze into the night sky, the stars and galaxies appear calm and steady, as though they have always existed in the same quiet arrangement. The patterns of light seem fixed, almost timeless. Yet beneath this peaceful appearance, the universe itself is slowly changing in a remarkable way. A space is gently stretching. This motion is not something you can feel beneath your feet, and it does not disturb the quiet rhythm of stars or planets nearby. Instead, it unfolds on the largest possible scales, gradually increasing the distance between galaxies across billions of years. The idea may feel surprising at first. It is natural to imagine the universe as a vast stage where galaxies move through empty space. But modern astronomy reveals something more subtle. It is not simply that galaxies are drifting through space. The fabric of space itself is slowly expanding. To picture this, you might imagine small dots drawn across the surface of a balloon. As the balloon inflates, the dots move farther apart from one another, even though none of them are moving across the surface themselves. The surface stretches, and the distance between the dots grows naturally. In a similar way, galaxies become more widely separated as the universe expands. This expansion happens gently and steadily. The distances between galaxies increase very slowly, far too gradually to notice within a single lifetime. Yet over immense spans of time, the effect becomes significant. Astronomers first discovered this quiet expansion by studying the light from distant galaxies. When they observed that light through powerful telescopes, they noticed a subtle shift in its color. The light from many galaxies appeared slightly stretched toward the red end of the spectrum. This effect occurs because the wavelengths of light lengthen as the universe expands. As space stretches, the light traveling through it stretches as well, becoming slightly redder by the time it reaches Earth. Now, by measuring how much the light shifts, astronomers can estimate how quickly galaxies are moving away from us. What they discovered revealed an extraordinary pattern. The farther a galaxy is from Earth, the faster it appears to move away. This relationship suggests that expansion is happening everywhere throughout the universe, not just in one particular direction. In fact, from the perspective of any galaxy, it would appear that distant galaxies are drifting away in all directions. This does not mean that our location in the universe is special. Instead, it reflects the way expansion works across space itself. Every region experiences the same gentle stretching. The expansion of the universe began long ago, in the earliest moments after the cosmos first formed. At that time, everything in the universe was packed into an incredibly dense and hot state. As space began expanding, matter spread outward and gradually cooled. Over billions of years, galaxies formed within this expanding environment, gathering stars and gas through the quiet influence of gravity. Even today, the expansion continues. Yet gravity also plays a role in shaping how expansion affects different regions. On smaller scales, gravity binds objects together strongly enough to resist the stretching of space. Within galaxies, stars remain gravitationally connected to one another. Planets remain bound to their stars. The solar system continues its calm motion without being pulled apart. Expansion becomes noticeable only across enormous distances between galaxies. Both this delicate balance between gravity and expansion helps shape the structure of the universe. Galaxies gather into clusters where gravity pulls them together, while the spaces between those clusters continue to grow larger. Over cosmic time, this slow stretching gradually increases the overall scale of the universe. Scientists studying distant galaxies have also discovered that expansion may be occurring slightly faster than once expected. Observations suggest that a mysterious form of energy spread throughout space may be gently accelerating the expansion. This energy is sometimes called dark energy because it cannot be observed directly, yet its influence appears in the motion of galaxies across the universe. Although its nature remains uncertain, dark energy seems to act like a subtle pressure that encourages space to continue expanding. Even so, the pace of this expansion remains extremely gradual. The universe changes slowly enough that the night sky looks almost unchanged from generation to generation. Stars still shine. Galaxies still glow softly in distant telescopes. The cosmos continues its calm rhythm, while expansion quietly unfolds in the background. When you imagine this process across billions of years, the scale becomes almost meditative. Galaxies drift farther apart like lanterns floating slowly across a dark sea. The space between them stretches gently, carrying them farther away without hurry. Light traveling across these growing distances takes longer and longer to arrive. The farther away a galaxy lies, the more ancient the light we receive from it becomes. In this way, observing distant galaxies allows astronomers to look back through time, seeing the universe as it appeared when it was younger and more compact. The expansion of space transforms the universe into a living story, unfolding across immense periods of time. From our small vantage point within the Milky Way, this motion remains invisible. Yet it quietly shapes the future of the cosmos, guiding galaxies as they drift slowly through the expanding fabric of space. And as this vast universe continues stretching outward in every direction, it still carries within it faint traces of its earliest moments, subtle echoes of ancient light that whisper about the beginning of everything. When you look at the night sky, it may seem as though the universe is made only of stars scattered across darkness. Yet beyond the glowing points of light, something far more subtle surrounds everything. It is a faint, quiet glow that fills all of space, a gentle remnant from the earliest moments of the cosmos. Long before galaxies formed, and long before stars began to shine, the universe existed in a very different state. In its earliest times, everything was much hotter, much denser, and filled with intense energy. Matter and radiation were tightly connected, moving together through the young universe like a glowing ocean of light. During this early era, the universe did not contain the clear darkness we see today. Instead, it was filled with a bright haze of energetic particles and light constantly interacting with one another. Photons of light bounced endlessly off charged particles, preventing the universe from becoming transparent. Imagine standing inside a thick fog illuminated by a bright lamp. The light scatters in every direction, making it difficult to see clearly through the haze. In a similar way, the early universe was filled with a luminous fog of energy. As time passed, the universe continued expanding. With expansion came cooling. Gradually, the intense heat began to fade, allowing particles to slow and combine into stable forms. Electrons joined with atomic nuclei, forming the first simple atoms, mostly hydrogen and helium. When this transition occurred, something remarkable happened. The fog that had filled the universe suddenly cleared. Light that had once been trapped began traveling freely through space. The universe became transparent for the first time, allowing radiation to move outward in every direction. That ancient light still exists today. Although billions of years have passed since those early moments, the light released when the universe first became transparent continues to travel across space. Over time, the expansion of the universe stretched those waves of light, lowering their energy and shifting them into a form invisible to the human eye. Today, this ancient radiation appears as a faint microwave glow that fills every direction of the sky. Scientists call it the cosmic microwave background. Sensitive instruments can detect this gentle radiation, even though it is extremely weak. No matter where astronomers point their telescopes, they find the same faint glow surrounding the entire universe. It is as if the cosmos itself still carries a quiet memory of its earliest light. This background radiation is remarkably uniform. Across vast regions of space, its temperature remains almost perfectly the same. The energy arriving from one direction closely matches the energy arriving from another. Yet within this uniform glow exist tiny variations, incredibly small differences in temperature that reveal subtle patterns from the early universe. These slight fluctuations represent regions where matter was distributed a little more densely or a little less densely during the universe's earliest stages. Over immense spans of time, gravity amplified those differences. The denser regions slowly gathered more material, eventually forming the first stars and galaxies. In this way, the cosmic background radiation acts like a snapshot of the universe when it was still very young. By studying its patterns, astronomers gain insight into how the cosmos evolved from a nearly uniform glow into the complex structure we see today. It is remarkable to think that every direction you look in space contains this ancient light. Even now, as you rest quietly, faint waves of radiation are passing through the room around you, having traveled across the universe for billions of years. They carry no sound, no visible glow, only a whisper of energy left behind by the early cosmos. The temperature of this radiation is extremely cold, just a few degrees above the coldest possible temperature known in nature. This chill reflects how much the universe has expanded since the time the radiation was first released. As space stretched, the waves of light stretched with it, gradually losing energy as they spread across the growing cosmos. The discovery of this faint background glow transformed our understanding of the universe. It provided powerful evidence that the cosmos began in a hot, dense state and has been expanding ever since. Before its discovery, scientists debated many ideas about the origins of the universe. The cosmic microwave background offered a clear clue that helped reveal the true story of cosmic beginnings. What is especially peaceful about this radiation is its quiet persistence. The light has traveled undisturbed for nearly the entire history of the universe, crossing galaxies, drifting through vast empty regions, and continuing its journey even now. It forms a kind of cosmic wallpaper behind everything we see. Stars may ignite and fade. Galaxies may collide and reshape themselves. Yet this ancient glow remains, a gently filling space as a reminder of the universe's earliest chapter. Astronomers have mapped the cosmic microwave background with extraordinary precision, using space telescopes designed specifically for this purpose. These maps reveal delicate patterns across the sky, showing how the tiny variations in temperature stretch across vast distances. Those patterns help scientists understand how the first structures in the universe gradually formed. From those early fluctuations, eventually grew galaxies, clusters of galaxies, and the enormous cosmic web that now stretches across the universe. In a sense, the background radiation represents the quiet seed from which all cosmic structure grew. The idea that such a faint signal can reveal so much about the past is one of the gentle wonders of science. By observing the universe carefully, astronomers uncover stories written in the light itself. Even though the cosmic microwave background is invisible to human eyes, it surrounds every star, every planet, and every galaxy. It passes through space continuously, moving with the same steady patience that has guided it for billions of years. If you imagine the universe as a vast and quiet landscape, this ancient radiation becomes like the soft glow of dawn that once illuminated the entire horizon. The dawn has long since faded, replaced by stars and galaxies shining across the night of space. Yet the memory of that first light remains. And as the universe continues its calm expansion, carrying galaxies farther apart across the cosmic sea, one small corner of that vast expanse holds a quiet spiral galaxy where a single star warms a small blue planet. After drifting through clouds of gas, wandering among distant stars, and exploring the slow motion of galaxies across the universe, it can feel calming to return gently to a familiar place. Out of all the immense distances and glowing structures in the cosmos, there is a small region where you currently rest. It is a quiet world orbiting an ordinary star, nestled within a spiral galaxy that drifts calmly through space. That world is Earth. From the perspective of the universe, Earth is small and delicate. It circles a star known as the Sun, which itself is only one of hundreds of billions of stars in the Milky Way galaxy. Yet within this small corner of the cosmos, something extraordinary has unfolded. Earth is a planet where oceans flow, clouds drift through blue skies, and life quietly thrives across forests, mountains, and seas. The journey of this planet begins long ago within the rotating disk of gas and dust that surrounded the young sun. Within that disk, small grains of matter gathered slowly through gentle collisions. Dust became pebbles. Pebbles gathered into rocks. Over immense stretches of time, these fragments joined together to form larger bodies. Eventually, one of those growing bodies became the Earth. At first, the early Earth was a far more turbulent place than it is today. The surface remained hot from the energy of countless collisions and the heat trapped inside the planet. Molten rock flowed across its surface, while the young atmosphere slowly formed from gases released deep within the planet. Over time, the surface cooled enough for water vapor to condense into clouds. Rain began falling across the planet for long periods, gradually filling low regions of the crust with water. Oceans formed, covering much of the surface with vast and shifting seas. These oceans played a quiet but important role in shaping the environment that would follow. Within the water, simple chemical reactions began taking place, guided by the elements that had gathered within the young planet. Scientists believe that over long stretches of time, some of these reactions produced the earliest forms of life. The details of this transformation remain one of the great mysteries of science. Yet evidence suggests that life began in Earth's oceans billions of years ago, emerging from simple beginnings into increasingly complex forms. From those early organisms, life slowly diversified. Tiny microbes spread across the oceans. Later, plants and animals appeared, gradually shaping the ecosystems that now cover the planet. The atmosphere also changed over time. Early life forms released oxygen as part of their metabolic processes. As oxygen accumulated in the air, it transformed the chemistry of the atmosphere and allowed new types of life to evolve. Over immense spans of time, forests grew across continents. Coral reefs formed beneath the oceans. Creatures of many kinds emerged, each adapting to the quiet rhythms of the planet. Despite all this activity, Earth remains a calm traveler through space. The planet follows a steady orbit around the Sun, completing one journey each year. Its rotation creates the familiar cycle of day and night. These gentle patterns help regulate the climate and energy that sustain life. The presence of the Moon also influences Earth's environment. Its gravitational pull creates the slow rise and fall of ocean tides, shaping coastlines and marine ecosystems. Even the tilt of Earth's axis contributes to the planet's rhythms. As Earth moves along its orbit, this tilt causes sunlight to fall differently across the surface, creating the cycle of seasons. These repeating patterns form the quiet background of life on Earth. From space, the planet appears as a small sphere wrapped in blue oceans and swirling clouds. Light from the sun reflects off the surface and atmosphere, creating the pale glow that distant observers might one day detect. In fact, astronomers studying distant stars often search for subtle signals that might reveal planets like Earth orbiting other suns. By observing the faint dimming of starlight or the gentle wobble of a star's motion, they can detect planets far beyond our solar system. Some of these distant worlds appear to lie within regions where temperatures might allow liquid water to exist. These discoveries suggest that Earth may not be the only planet where life could arise. Across the Milky Way galaxy alone, billions of stars may host planetary systems. Among them, there may be countless worlds with oceans, atmospheres, and landscapes shaped by the same natural processes that formed Earth. This possibility adds another layer of quiet wonder to the universe. Yet even if life exists elsewhere, our own planet remains a remarkable place within the cosmos. It is a world where consciousness has emerged, allowing living beings to observe the universe and reflect upon it. You, sitting quietly beneath the night sky, are part of that story. The atoms within your body were forged long ago inside ancient stars. Over billions of years, those elements traveled through space, gathered into clouds of gas and dust, and eventually became part of the planet where you now rest. In this sense, you are connected to the larger universe in a very real way. Every breath you take, every thought you have, is linked to processes that began long before Earth formed. When you step outside at night and look toward the stars, you are seeing the same cosmic environment from which your planet emerged. The stars scattered across the sky belong to our galaxy, which itself drifts within a vast universe filled with other galaxies. Beyond the Milky Way stretch immense distances where countless other cosmic structures quietly evolve. And yet, despite this immense scale, your experience of the universe remains peaceful and immediate. The gentle warmth of the sun during the day, the cool quiet of the night, the soft glow of the moon above oceans and forests. These small moments connect everyday life to the grand story of the cosmos. As this journey gently comes to a close, notice how wide and still the universe feels. So many stars glowing quietly, whether we see them or not. You don't need to keep their names or distances. They've already done their work. If you enjoy these slow explorations, you can support the channel in any small way that feels natural, so others can find this calm too. But right now, there is nothing to decide and nowhere to go. Let your thoughts soften, your muscles relax, and the night carry you onward, one peaceful breath at a time.